Yeah, so as Matt said, my name is also Matt. I work at Google's device management team in New York. The best way to describe what we do is we roughly try to occupy like the overlap sections in the Venn diagram of our various platform teams. So we try to build cross-platform solutions for our employees and the ops teams. And so today I'll be talking about our binary whitelisting system that we've built. I'll be focusing mainly on the Mac side of things, obviously, but I'll cover a little bit about our Windows support later on. So I think the best place to start is the problem that we're trying to solve here, which is malware, right? I know I'm just preaching to the choir at this point. I mean, we're all used to seeing headlines like this on an almost daily basis. And unfortunately, it doesn't look like it's a problem that's going away anytime soon. So what can we do to combat it? One option is antivirus, right? This obviously isn't a new solution, but it can have some effectiveness against malware. However, it does come with some trade-offs, right? Its effectiveness is essentially tied to the signature updates that we get from the antivirus vendors. It can have impact on system performance, which can't be overlooked. And because it's a complex and privileged software, vulnerabilities within the AV software itself can be very serious. So what are some other options? We could trade all of our laptops in for iPads, right? That's a viable option. We could all start using Chromebooks. Not that I'm biased or anything.
We did start using them.
That's great. Hey, that's great. I don't know if I get credit for that, but anyway. Or maybe we just give up and stop using software altogether. Or we might also try binary whitelisting. This is I'm a bit biased here too. This is sometimes also called application whitelisting, but the rough idea is that we have a system where we're dictating what a user can and cannot execute, and we're doing that by maintaining lists of hashes of the binaries in question. So there are generally two different policies you can go with in a system like this. The first is your default allow policy. Basically what you do is you maintain a list of hashes of known malware and you prevent that malware from executing. This also has some pros and cons. The pro is that your users are unlikely to even notice that their security posture has changed, much less feel inconvenienced by it. But the downside is that you're only stopping known malware, and so it's really not a great solution. The other side is a default deny policy, and this approach, if you can get it to work, does have some real potential for stopping malware, because what it means is that you're blocking the execution of all malware, whether you even know it's malware or not, whether a user even knows they're executing something or not. And the trade-off is a big one. The trade-off is that now you have to maintain a list of all the things that are allowed to execute on your system. Which really boils down to a problem with scaling, right? The more diverse your software landscape gets, the harder this problem becomes. So consider a scenario where you say have 100 machines and a fairly homogeneous software distribution among those. In a case like this, humans could probably handle the approval load of the policy changes that you'd need to make. But at Google, we're dealing with over 100,000 user machines and a vast diversity of software that can run on them. So throwing more humans at the problem is just not an option for us. But maybe there's a way we can make it work. So we come up with this approach that we call social voting. And what this does, it takes the principle of a peer review or a code review and applies that to your policy approvals. So instead of scaling up our support staff, we just distribute the workload out among the users. Our Obviously, the biggest risk here is that users are going to accidentally approve malware, but we take some steps to try to minimize that risk. The first is that we surface virus total analysis results to the users before they vote on anything. And the second is we try to reduce the impact of accidental malware approval with what we call local whitelisting. So how does this work? So let's say you have some application, because that's what that is, a universal symbol for computer program, right? And you have some fleet of devices that could potentially run it. So every time a new binary comes along, it's assigned a score. The score starts at 0 and can proceed up through 2 different thresholds. There's a low local whitelisting threshold and a high global whitelisting threshold. So every user who wants to run this application is allowed to cast a vote. Each vote counts as a point. And as the score increases, eventually it's going to cross the local whitelisting threshold, at which point the machines of the users who have voted can now run this binary. Every additional vote slowly widens the pool of machines that are allowed to execute it. And then when and if it finally crosses the global threshold, it's approved for all machines across the fleet and voting stops. So it's really worth pointing out the benefits that this can provide. First of all, it empowers our users to run what they need to run without having to defer to lengthy human or ticket-driven approval processes. Most importantly, it limits the lateral movement of an attacker if malware does get approved. The infection is going to be restricted to the subset of machines that have an approval for it, and the malware isn't going to be able to run additional malware because it's going to get blocked. And honestly, it puts us in a position where we don't have to trust our users 100%, which sounds terrible now that I say it. So what do we need to build to make something like this work? So first we need an enforcement mechanism, which some of you are well familiar with in the form of Santa. So I'll just take a brief minute to kind of go over what it is and what it does. I get the sense that most of you are pretty well aware of Santa. So Santa is a binary enforcement system that was built by our Mac operations team. It's able to control executions on a per binary and per signing certificate basis. And has been on GitHub for just over 3 years now. It provides 2 different enforcement modes. The first is called monitor mode, which corresponds to the default allow policy we were talking about earlier. And the more restrictive lockdown mode corresponds to the default deny policy. And internal testing that's been done shows it's able to do all this with a very minimal overhead. So back to our requirements. We've got our enforcement mechanism taken care of, and as I'm sure most of you have guessed, the remaining 2 are handled by a single application, which we call Upvote. So what is Upvote? Upvote's an App Engine application we built that acts as both a central policy server for our Santa clients and a user-facing social voting interface. It's written in Python 2 and a web app. We use Cloud Data Store for our persistence layer, and the front end is written in Angular. It's been deployed for around 2 years now and handles the syncing and approval load for over 100,000 employee Macs and Windows machines. And is able to do this all with a very small engineering team, which I suppose is more of a testament to the power of App Engine than it is to our engineering prowess. And last but not least, it's on GitHub today. We released it in March of this year and have been gradually getting the word out. And I just want to mention that this is by no means a signal that we're wrapping up development, dumping a repo, and moving on. It's still very much under active development, and we have a number of features and improvements in the pipeline, a few of which I'm going to talk about in a little bit. So before I get to the future, I want to talk a little bit about what Upvote can do today, current features. So as I said, it acts as a policy server for all of our Santa clients. So the Santa clients sync against Upvote, and when I say sync, what that really means is that the Santa clients make a series of HTTPS requests, each of which serves a different purpose. One request uploads data about recent applications that have been blocked. Another one downloads policy updates, and so on. Santa does this once every 10 minutes, but that interval can be tuned administratively. It's also worth mentioning that there's an immediate request sent anytime Santa blocks anything. It uploads metadata about the application that was blocked to Upvote so that that data is there ready to go when the user subsequently navigates to Upvote. So if Santa's blocking all of this stuff on our Macs, how do we ensure that it doesn't block critical parts of macOS itself? Furthermore, how do we prevent users from getting pop-up fatigue from Santa and either making bad decisions or ignoring blocks altogether? The answer to both of these questions is that in addition to binary whitelisting, Upvote and Santa also allow for certificate whitelisting, meaning that any binaries that have a whitelisted certificate in their signing chain are themselves also whitelisted. So thanks to all the code signing that Apple does, we can put key Apple certificates in Upvote and ensure that users will never see a block from something that's either a part of macOS or has been downloaded from the Mac App Store, if anybody does that. This particular feature, though, is only available to admins. Users can't vote on certificates. So I want to talk a little bit about a really painful use case we ran into early on in our deployment of this. So we were gradually moving more and more of our Macs into lockdown mode, and Santa was doing its job and blocking any unknown binaries that were being executed. And then we were asking users to go and vote and get these binaries approved. And this becomes a real problem when you consider the fact that Mac.apps are often composed of a lot of binaries. So someone installs an update for 1Password, they try to launch it, it runs binary A, which the code has changed, so the binary has changed, so the hash has changed, and so it gets blocked. So okay, they get binary A voted on and approved. Now they can launch it again, it runs binary A. Binary A turns right around and runs binary B, which gets blocked, requires votes, approval, binary C, so on and so on. So this was causing a lot of pain for our users, and we came up with something we call bundle voting. What this means is that Mac.apps can be voted on as a single unit. A user launches the app, they get one block, they go through one voting and approval process, and the entire unit of binaries is approved. So talk a little bit about Windows, popular topic, I'm sure. So for Windows, on the Windows side of things, it's a little bit different. For that we use a third-party solution for our enforcement, Carbon Black Protection, which some of you might know by its previous name of Bit9. In this case, the Bit9 client acts in a similar role to Santa. It enforces policy on the Windows machines and syncs with an intermediate Bit9 policy server. Upvote, in turn, integrates with that server and is able to pull data about applications that have recently been blocked and then push back policy changes that are triggered by user voting. The big takeaway here is that if you're already a Bit9 customer, you can just bolt Upvote onto your Bit9 policy server by pointing it at the REST API, which should already exist on that policy server. The last thing I want to talk about is data analysis. So I mentioned we use data store for our persistence layer, but that's really a representation of kind of the current state within the application. We have an almost daily need to analyze all the data that Upvote generates. Run one-off queries, look at data trends, things about like execution history, voting history, and so on. And for that, BigQuery has proved to be a much better solution. Upvote has the ability to optionally export auditing data to BigQuery in near real time, which you can use SQL to just slice and dice however you want. It's been a really great solution for us. BigQuery also has a well-documented API that you can integrate with for your own analysis needs. Or you can even take it a step further and use something like Google's Data Studio. This sounds like a commercial, doesn't it? You can use Google Data Studio, and you can use that to build like charts and graphs off of the data that Upvote is exporting to BigQuery. So that's a real quick discussion about current features. I'll talk a little bit about what's on the horizon. Push notifications. This is going to be really awesome. So the idea here is that Santa clients will no longer have to wait for their next sync interval to receive policy updates from Upvote. Upvote will have the ability to trigger syncs among various clients by way of Firebase cloud messaging. So this has two big implications for the users. The first is that a user will be able to run a binary within seconds of voting on it, which you'll see in a moment. And equally importantly, it means that malware bans can propagate through your entire fleet within minutes. Lockdown exemptions. So as great as lockdown mode can be, it's a bit unrealistic to think of it as like a one-size-fits-all solution. So what we want to do is provide a simple yet safe mechanism for users to opt out of lockdown mode if it's causing them undue pain in their job. And we'd rather not have to rely on humans. We'd rather rely on humans as little as possible for this approval process. So the idea here will be that a user can go into Upvote, select one of their hosts, request a lockdown exemption. That request then goes through a series of policy checks. If they all pass, they're automatically switched into monitor mode out of lockdown mode. And our aim is to build this in such a way that open source adopters can kind of fill in the blanks and plug in their own policy checks if that's something they want to do. Finally, something that we're calling transitive whitelisting. So lockdown mode can be especially painful for users who have to compile things. So like Mac ports users, homebrew users, things like that. The idea here is that you'll be able to administratively bless a compiler binary within Upvote. That blessing will then propagate down to the Santa clients, and any binaries that are produced by that blessed compiler will then be able to run without being blocked on that machine only. So we're hoping that this will be a nice intermediate solution for users who want to be in lockdown mode but still need to compile things on their machines. So a live demo terrified me, so I decided to do the next best thing and took a screen recording of me going through a typical approval process in Upvote. So in this case, I have my corporate Mac. It's running Santa in lockdown mode, and I just installed a new application. Daisy Disk is a really cool utility if any of you guys use it. And so I'm going to try to run it. So Santa blocks it, and immediately in the background, it's uploading metadata about Daisy Disk to Upvote, so it's there and ready when I open Chrome. It gives us some details about what was blocked, and down at the bottom has a button that says Open in Upvote. So we're going to click on it. Sometimes Mac OS, it doesn't like when executions are interrupted, so we'll dismiss that. And this is Upvote. So this is the metadata that was just uploaded, and a couple things worth pointing out, if you can see. The first is that since this is a .app, there are actually 4 binaries here that we're going to be voting on as a unit. Second, this particular application already has a score of 5, putting it past the local whitelisting threshold, which means we just need to cast our additional vote, and we'll be able to run it. So if we scroll down, we can see that VirusTotal has already analyzed this in the past and has found that there's nothing troublesome there. And finally, we're presented with 2 buttons, either vote to whitelist or flag possible malware. So we're going to click to whitelist it, and almost immediately, Upvote is going to allow us to run this. It's going to ping Santa with a cloud message, FCM message. Santa syncs, and then notifies us that the binary can now be run. So if we go and try to run it, what's going to happen? Here we go. So, hey. So that's Upvote in a nutshell. As I said, it's already available on GitHub as a companion for Santa. We have a Google discussion group if you have any questions or comments. Myself and some of the members of our MacOps team lurk on the Santa channel. I'm at Chief if you want to message me directly. or you can email my corporate email,